Hello, fellow humans, and welcome back to Beyond Words. In this episode, I'm joined by Dr. Jill Kries, a cognitive neuroscientist whose work explores how the brain transforms raw acoustic speech into meaningful language using EEG, naturalistic story listening, and innovative approaches to studying both typical and disordered populations. We dive into her research on aphasia, and it really challenges how the traditional view of aphasia is just a language disorder, purely a language disorder. Instead, her research shows how breakdowns can occur much earlier in the processing stream, so what we think of as speech, so at the level of phoneme perception, acoustic discrimination, and even basic auditory dynamics. From ambiguous ba to da categorization tasks to neural encoding of speech sounds over time, we explore how weaker or shorter-lived processing of key phonetic information can cascade into higher-level language difficulties. We also talk about lexical entropy, how the brain manages uncertainty in real time, and how people with aphasia might not sustain processing of the most informative parts of speech long enough to fully resolve meaning. Along the way, we connect this to dyslexia, statistical learning, and the broader idea that speech and language are far more intertwined than we often assume. This episode is a great reframe for aphasia, not just as a disorder of words and grammar, but as a disruption across the full hierarchy of speech processing, from sound to meaning, and opens up new possibilities for both assessment and intervention. So, what lies beyond the words we speak? Tune in and find out. Hey everyone, welcome to Beyond Words, conversations on language, music, and mind in collaboration with speechtherapypd.com. I'm your host, Garrett Oyama. I'm a musician, practicing SLP, and a PhD student with an interest in all things language, music, and cognition. I'm so excited that we have Dr. Jill Kries with us today. Dr. Jill Kries is a cognitive neuroscientist whose research investigates how acoustic speech signals are transformed into meaningful language in the brain. Using EEG and naturalistic story listening paradigms, her work examines neural encoding across both low-level acoustic features and high-level linguistic structure. Dr. Kries studies speech and language processing in neurotypical individuals, as well as clinical populations, including individuals with aphasia, dyslexia, and pediatric epilepsy. Her research aims to bridge cognitive neuroscience and linguistic theory to better understand language disorders and inform future diagnostic and intervention tools. Before we get started, just a couple of items to mention. Most of these upcoming podcasts, including today's, will include an accompanying course on speech therapy PD that is available for 0.1 ASHA CEUs. A couple of disclosures: we each receive compensation from Speech Therapy PD for this podcast, but there are no other relevant non-financial disclosures to report. So without further ado, Dr. Kries, welcome to Beyond Words. How are you doing?
Thank you so much for having me. How are you?
I'm doing well. I always ask the guests a little bit about their origin story, just because I'm so interested in how people come to this very specific field of language and the brain and all of that stuff. So yeah, how did you get started in this field?
Yeah, it's a good question. I am from Luxembourg, which is a very multilingual country. And as a teenager, so from age 16 on, I worked as a camp counselor at camps for kids in Luxembourg. And these camps had kids that were neurotypical and also neurodiverse kids. For example, children with epilepsy or with autism and so on. So that first sparked my interest in learning more about what causes that neurodiversity, those disorders. And yeah, so that is how I got interested at first, to study maybe psychology, to understand the brain. And yeah, from there, I had like a cool psycholinguistics class in my third year of undergrad. And then during the master's, which was in clinical neuropsychology, I got interested in language processing, just because I've always been fascinated about how we communicate and can like transmit ideas like almost instantaneously. You understand what I mean to communicate, so that's just super fascinating. And then during a clinical internship that I did for my master's as well, I was working in Aachen in Germany at the university hospital for like 3-4 months. And there they have like inpatient aphasia intervention unit there. And so I worked a lot with patients with aphasia there for mostly cognitive diagnosis. after stroke or due to other neurological disorders. And that way I got interested in aphasia and generally in language. And then I looked for a PhD that was addressing these kinds of topics.
So cool. Yeah, you're my first guest ever with a camp counselor background. Um, well, it's something that maybe we should talk about your work in aphasia. I work in development, so I don't work in with a lot of, patients with aphasia. I did a little bit in grad school. But, I think a lot of SLPs, there's this traditional framing that tells a story about these specific language deficits in aphasia, not relating to speech per se or speech perception. But your research is kind of telling a different story and maybe opening up this conversation a little bit more. So can you talk a little bit about that?
Yeah, during my PhD, I did this big data collection, which I will talk about more, I think, during this podcast. But it had the traditional kind of language tests, so focusing on more like semantics and syntax. But then we also wanted to include some lower level tasks like auditory processing and speech processing, speech sound processing. And I did my PhD at KU Leuven at the experimental ENT lab or experimental ORL lab. So they were very focused on hearing tests and stuff.
Hmm.
So I used tests that they have previously used in other kinds of experiments that are not with patients with aphasia, but for example, a phoneme identification task where patients heard a ba or a da sound and they had to say which one it was, but it was not as easy as I just said it because we manipulated the stimulus experimentally so that it sounded very ambiguous between ba or da, so as to see how well people can categorize the speech sound when it is slightly different each time. So what we call invariance. The brain processes the same sound, for example, whether I say ba or ba, like it's processed
Mhm.
as the same sound in the brain. It's always the same identity of the phoneme that you heard or syllable that you heard. So yeah, that we wanted to see if an aphasia was also already impacted at these lower levels. And we indeed found that that was the case in a sample of people with aphasia, 39 people with aphasia that were quite heterogeneously recruited. We had patients that had a left hemisphere lesion or bilateral. And yeah, the largest lesion overlap was in like left inferior frontal gyrus, but it was broadly spanning overall throughout our sample. Yeah, the left hemisphere, like left temporal lobe, left frontal lobe. Um, so yeah,
Yeah.
and that
Yeah.
was compared to a control group that was demographically matched to our aphasia patient group. And yeah, we saw that actually more than half of our aphasia patients scored below threshold on that task.
Mm. Yeah, that's so interesting. It made me think about so our ability to categorize sounds like that invariance um, notion that you mentioned. It's sort of like a measure of expertise, right? Because your ability to actually ignore. Yeah, I talked to this one researcher a while ago, and he was saying that our ability to ignore stuff is actually a superpower. And like,
Yeah.
so when you are, young and you're developing, you actually are first able to hear all the sounds across all the different languages. But as you become an expert in your particular language, you have to ignore a bunch of the variation that exists in between those two. Like you mentioned, ba and da, in between all of the other phonemes, right? There's a bunch of like graded variation between those phonemes, and you actually have to like ignore all that stuff and put them into the proper categories that exist for your language. And without that like kind of capacity, that causes a bunch of problems, and also like not just here, but in development too. Like people with dyslexia, for example, have trouble that like their subcortical responses to the different sounds like are uh, like they don't collapse into those categories as easily. So they're hearing like kind of those all of those in between gradations, and they're categorizing them as separate. So it seems like maybe that's what's something that's going on, which is really, really tied to language. So
Yes. Yeah, exactly. We do that all the time. We categorize so many things in speech and language and in the world in general. So that is indeed like a superpower and maybe what is part of what is going wrong in some people with aphasia after stroke. So, yeah.
yeah, yeah, that's so interesting. Is that what you mean by weaker phoneme processing, or is that something separate?
That is probably from another study, which was based off of EEG measurements.
Okay.
Yeah,
That's right.
we
That's
can
right.
talk about.
Can you talk about that one a little bit? That's a really
Yeah,
cool one.
sure. Yeah, so that one is we had the same group of participants with aphasia and healthy controls listen to a natural story while we recorded EEG data. So when you have electrodes placed on the scalp, and that way we can record neural activity while you do some task. And in this case, listening to a story, natural story. And then afterwards, we can annotate the story that they listen to for whatever features we are interested in. And in this case, we were interested in phonetic features. So that means whether a phoneme was, for example, a vowel or a consonant, whether it was a fricative sound like a f, or a plosive sound, and so on. So there are different ways we can characterize all kinds of speech sounds. And so we looked at how well is that phonetic feature information encoded or represented in the brain in the aphasia group and in the control group. And we found that, so we do this in a time resolved manner because EEG gives us really good temporal resolution. So we can see at each millisecond
Mm.
how well does the brain process the phonetic features right after they hear a phoneme. So we like time align the brain data with the onset of phonemes. And then we see that between 80 and 250 milliseconds after they hear a speech sound, a phoneme, people with aphasia showed lower encoding of these phonetic features.
Mm.
So in
Okay,
this
got it.
specific time window after hearing a sound.
That's right. That's right. So it's like not just a problem of phoning order, but like time on task, like for processing these phonemes, like being able to stay on like the phoneme for long enough.
Yeah. So yeah, we did this study because I actually thought maybe these phoneme related problems can carry over to word level processing problems. And with the hypothesis that maybe people with aphasia would mix up the order of phonemes in a word so that
Right.
maybe because sometimes we see in phonemic paraphasia, so when they produce speech, that they mix up speech sounds. For example, table, and then that would be like Betel or
Fatal. Yeah,
yeah.
something like that.
Just to give an example. And so that was my initial hypothesis. But we tested this as well with this decoding approach called temporal generalization decoding. And we saw that actually it was not that they mixed up the order of phonemes, but rather that there was weaker encoding of certain phonemes because we did like a follow-up analysis to see which phonemes were actually processed in a weaker way or
Mm.
less strongly. And we found that phonemes that carry a lot of information about the lexical, about the word that it is, those were processed not long enough in the aphasia group, but they were processed longer in the control group. And I can maybe already explain what I mean with phonemes that carry more information about what the word identity is
Yes,
going to be.
please. I
Yeah,
was going to ask about that because
yeah,
I think that's a really important, it's just
yeah,
a cool concept. I think it's a important one for SLPs to know about.
yeah, totally. So with Shannon entropy, like a mathematical formula,
Hmm.
we can quantify how uncertain one is at each phoneme position in a word about what the word is going to be. For example, if we have the word friend, you just hear at the beginning the sound f, and many possible words start with the phoneme F. So we don't yet know what the word is going to be if we only have that input. And the activated cohort of words is really big. So we are very uncertain about what the word is going to be. And then as the next sound comes in, like fr, there are already a few less words that are in that cohort. And then we get even more input, fre, and then the activated cohort gets smaller and we are less uncertain what the word is going to be, and so on, until we have the full word and we know what the identity is. So these first letters or phonemes generally in a word, in a spoken word, will be more important to maintain for longer because they are really important to understand what the word is going to be. And those seem to not be encoded as long or long enough in the aphasia group that we had compared to the control group.
Got it. Got
Yeah.
it. So the ones that is this what you term lexical entropy?
Yes. Yes.
Okay, got it. So is it high entropy that if
High
the
Yeah, high entropy means high uncertainty about the word identity at this phoneme position. So the earlier phonemes generally have a higher entropy.
and those ones are not processed long enough?
Yes,
Because
exactly.
like yeah, it makes sense that you should be processing those uh if you're the ones with that are less certain, you should
Yeah.
process those for longer, right?
Yes.
Yeah, it kind of reminds me of, I guess it's a similar concept in development to the like statistical learning concept.
Mm.
So, like Jenny Safran's work, shows that babies are attending to these particular statistical patterns in language. Like, if you have, I think her example is like pretty baby or something like that. Um, if you have pra, it's more likely that you'll likely see a T after it, versus
Mm.
like T Bay is like very improbable.
Yes.
So that helps kids or infants separate where word boundaries might be, because actually we speak in a pretty continuous stream. So um,
Yeah,
yeah,
exactly. Yeah. I
really
think
cool concept.
statistical learning is also would is super interesting to analyze even in a population like aphasia as well.
Yeah, yeah. I wonder if that's something that's like a part of aphasia, is that some of those uh, statistical predictions are like maybe uh, they're not accessing those.
Yeah, yeah, that's a good hypothesis. I don't
Yeah,
know. I know one colleague has looked at statistical learning in aphasia, but more with MRI in relation to MRI. So we'd have to look that up more.
yeah. Well, I wanted to ask you about like, so you use this like natural story listening instead of a more like a classic word task or something like that. Um, how does this like why did you make this choice? Why is it helpful to use, potentially helpful to use these natural stories?
Yeah, that's a really good question. I think for multiple reasons. And the first one, I think for me, is that patients or people with language disorders often have more problems with actual everyday communication, functional communication, in order to go about their lives and do their things, rather than doing language testing with like isolated like words. I mean, they also show problems there because especially if the test is sensitive enough to even capture like mild problems. But yeah, I think there's maybe, I mean, maybe the SLP community can comment on that. Maybe is there a shift a bit for at least some people with aphasia to move more towards functional communication interventions, where people learn to actually apply what they learn in therapy also in everyday situations.
Yeah.
And so I think therefore it's interesting to study how the brain reacts during natural language. And yeah, so that was one big motivation to do that. And then a second reason was that with this kind of approach to studying language with natural stories. As I mentioned before, we annotate afterwards the stories with features that we are interested in of studying. Like, and with features, I mean, for example, you could annotate the phonetic features, as I mentioned, or which phoneme it is that they are hearing, but you could also annotate the acoustic stream, like how is the volume changing during speech, or you could annotate more semantic type of features, like how surprising is a word given its context, or even syntactic features, like at what part in the sentence do phrases close, like phrases
Mm,
end, and the information all gets integrated. So at what point is
mhm.
that happening? Like, and many more. And even now with large language models, people look at similarities between the brain and embedding layers of these large language models and so on. So with natural stories, you can really the hypothesis space for what you're researching is large
I
almost.
see. Yeah, yeah. You could
Yeah.
do a lot with, yeah, there's so much going on in the story. And I think it's
Yeah.
I'm totally on board with naturalistic stuff. I mean, I've talked to so many people, researchers who just, context is so important. We encode context in everything that we do. And like a lot of times as speech therapists, we might be working on a particular sound or like a word, and maybe they can say that they're working on velars like a K or a G or something, and they could totally say it when we're working on that word together, and they're making the K sound, the G sound, and then when they're in regular life, they're telling a story, they're like fronting it every time, and um, I think there's something specific about like how we generalize and how we do things, and like they're kind of like motor patterns that we have tied to these particular contexts. So I think it's really important to get at not just for speech sounds, but for how we use language broadly, like get at what's most natural, what are they actually doing in
Yeah.
kind of real daily life. So
Yeah, exactly. And like the word tree, for example, can like be accompanied by a whole set of different contexts in a situation A and a situation B. So it's important to take that into account. And yeah. And there's so
yeah.
many interesting linguistic phenomena happening in natural speech that we can then afterwards dissect and analyze how the brain reacts to all of these phenomena.
Yeah, that's so cool, really rich. um what do you think, you know how much of the language difficulties in aphasia do you think comes down to kind of these lower level aspects of speech processing or speech? Um, do you
Yeah.
think that I mean, to me, it seems like, based on your research there, and, this totally makes sense with a lot of the neurosciences, that speech and language really can't be separated so easily. They're like very intimately connected. But yeah, I'm wondering how much you think, if you can even put a number to it, which I don't think you can, but like, what would you say is the split there?
Yeah. Well, as you said, I don't think you can totally put a number on it, but
Yeah.
you can study it in different ways. Like, I think one thing that would be super interesting to do as a follow-up study to what I did doing my PhD work, which is like recruiting broadly everyone that has some sort of aphasia and not really making a difference between where the location in the brain is and so on. I think it would be interesting with this same kind of paradigm, like natural story listening in aphasia, try to recruit people more narrowly as to where their lesion location is and or what their symptoms are, as well as I think something that neuroscientists often forget is to also look at white matter connectivity. And I think that is also something to really take into account in future research. So yeah, so much to explore. And I think
Interesting. Yeah.
as to yeah, coming back to your question,
Yeah.
um, so in one of my studies, we found that for that phoneme identification task that I talked about earlier, over half of 40 or 39 people were impaired at that task. And then we also had a second task in that study, which was even lower level. So where people heard noise sound and it was rising with different speeds, like the patient or the person would
Oh,
hear
yeah.
three noise sounds like shh, shh, shh. That was really hard to mimic. But maybe you heard that the third one was like rising, the amplitude was rising at a slower rate. And so that
uh,
was a task to discriminate which of the three stimuli was rising with a different speed rate or rate than the other two. And so that's really lower level, but it turns out that is
right.
something that is a skill that is really important for speech processing because at the beginning of, for example, syllables of words, or just can also be in the middle of a word, there is a steeper or shallower rise of the amplitudes that is just like happening naturally during our speech. So this is a really important skill for yeah, for understanding speech and yeah.
Right. Yeah, I imagine because like yeah, the harmonics, the FM sweeps. That's what makes that's the really the difference between a like a ba and a da or a ga is like you're right that very the sweeping harmonic changes
Yeah,
in the sound.
exactly. In the ba and the da, it was the second formant slope, whether it was downwards or upwards. But anyway, I will not go into detail
Oh
about
no, that's great. I like that.
it.
Yeah. Second
But
form and slope. I'll remember.
but yeah, in that other even lower level task, we also found that over 50% of our sample showed below threshold performance on that. So, and the participants that were impaired on that task were not necessarily the same ones that were impaired on the phoneme identification task. And
Oh,
so
interesting.
overall, there were around, I think, I have to double check this, but I think around 70% of our sample of 40 participants that had some form of lower level processing impairment.
Mm,
So it might be larger than what aphasiologists think. So I think
yeah,
it's definitely super interesting and important to further investigate.
absolutely. Did you see any correlations between maybe severity or type between those that did have the lower level um, kind of different impairments? Um,
Yeah, we looked at correlations with different kinds of language tests, and we did find one with a phonological test that was, for example, it was like four small subtasks in that score. And the tasks were like identify the first sound of this word that you heard, or what other tasks were? I don't remember right now, but
yeah.
it is documented in the paper. But yeah, so these kinds of a bit higher level phonological processing tasks, like yeah, what is the beginning sound of a word? Which words rhyme? These kinds of tasks seem to be um, getting or missing some input because that lower level function is impaired. So it
Mm,
might be that that propagates even higher up the language processing hierarchy. Maybe it affects even word
yeah.
level, but so far we haven't found that. But I think future research could look into
Yeah.
that more.
Well, it seems like this could be a really important and helpful tool potentially for evaluation, right? Like an assessment battery. Do you
Yeah.
think?
Yeah, I was yeah, kind of shocked to find that almost like in the SLP practice, like these lower level functions are not really assessed that much. Like phonological, sure, and some tasks I think address a little bit like phoneme identification, but even lower than that, I think is often not assessed and also not trained in
Yeah.
intervention. So that's definitely an area that, yeah, some new tasks could still be developed.
And I think it opens up new avenues for intervention, or sorry, for evaluation too, right? Like if you're able to get, so with like Nina Kraus's work, she uses the FFR, the frequency following response, like a subcortical response. Like you can then test to see, like in with patients with aphasia, like you can do that without them needing to have any language. So like even if they're not talking, you can have them listen to something and you can get an FFR and you could really see, is there like this biological bottleneck here that's like, preventing, or contributing to this language deficit. And then, like different types of intervention would be called for there. And they probably wouldn't be the higher level language stuff. Um, Although, yeah, it is all
Yeah,
connected. So,
yeah,
yeah.
it is all connected. But yeah, that's super interesting as well.
Any thoughts on how this might change like intervention? So, like, or is there any do you have any thoughts on like something like a perceptual training or um
Yeah.
discriminating contrast? But do you think that that would help?
Yeah, I think, yeah, these kinds of like honestly what we used for evaluation or assessment of this could also be developed into like a practice tool or training tool. Like you can administer it on an iPad with just headphones, and so it's quite practical to even just do at home. If yeah, if people,
Yeah.
one could build an app like that, for example. Um, yeah, I think that could be really good.
Yeah. Well, it's making me think of so many things too, because like one is like, like we mentioned, it's like breaking down this old story, but it's also like, oh, I wonder if like even something like hearing aids would be helpful. If you're struggling with understand like speech perception at a
Mhm.
low level, you can optimize that input in different ways. Um,
Yeah, that's
so
true. I hadn't even thought about that yet, but yeah, that's actually super interesting. I hope that other people have thought about that and are maybe taking that direction for research.
yeah, well,
Exciting.
maybe future collaboration there. We'll see.
Yes, reach
Um,
out to me.
yeah. Um, so maybe we could talk a little bit about your work with dyslexia.
Mhm.
Um, yeah. What's the best way to describe like the core difference in phoneme processing for
The
individuals
core
with
difference
dyslexia
with compared to aphasia or compared to
compared to like maybe typical
yeah.
development?
So just a little disclaimer, I'm not a dyslexia expert, and the dyslexia work that I have been involved in has been led by Marlies Gillis, a postdoc at KU Leuven, and with Maaike van der Mosten. And yeah, so dyslexia is generally defined as a reading disorder, but some research or much research actually shows that there are lots of problems with phonological awareness. So again, what I already mentioned for the aphasia study as well, there's like, can you identify the first sound of a word, and can you find a word that rhymes on the other word, or say which word rhymes on word B. And so yeah, I think that is mainly what the dyslexia research defines it as.
Hmm.
Um, yeah, but in my research, or in Marlies and I's research, we have looked at it at yeah, story listening with EEG again, kind of the same paradigm as we did with the aphasia group. And then also the same kind of analysis methods that we did for the aphasia group, so phonetic feature decoding. And we did that because dyslexia is known to be a yeah, phoneme and phonological processing disorder as well. So that's why we were interested in seeing whether phonetic feature encoding would be altered in some form in dyslexia compared to neurotypically developing children. And yeah, so that was the data set and the methods set up and why we did it. And we found that children with dyslexia seem to prioritize in an inefficient way which phonemes to process more. Like concretely speaking, they processed the phonemes with lower entropy. So actually, these lower entropy phonemes are less important for identifying what the word is going to be. So they should not be processed as strongly as other phonemes. And it
Mm.
seems that children with dyslexia process them sort of too strong. So they inefficiently prioritize these phonemes that actually don't give you as much information about what the word is going to be. So
Mm.
that seems, based on our research, to be yeah, mechanism of dyslexia.
Got it. So I guess just to recap, in your aphasia study, it was kind of like not enough processing. Like there's a weaker phoneme processing, and it that wasn't enough time spent on those higher entropy sounds, the ones
Yeah.
that are more ambiguous. And whereas in dyslexia, you actually have too much processing, but it's being kind of spent in the wrong place, where like the low entropy phonemes, which carry less information that could ignore, or maybe distribute your processing elsewhere, are being extra processed.
Yes, exactly. You summarized it
Interesting.
super well.
Okay, cool. So yeah, I guess that makes sense. I'm thinking of one thing that I learned from um, Nina's book again, from the Sound Mind, that they are. Um, so we were talking before about those category boundaries between phonemes, and apparently individuals with dyslexia, they actually, their category boundaries remain more flexible throughout life. So they're processing that, like when we were talking about those gradations, like they're processing those different sounds, um, like they're not collapsing into those categories as effectively. And they've shown how individuals with dyslexia will be able to hear sounds outside of their native language more easily.
Mm.
Um, but yeah, just something that I thought was interesting and kind of related is that it is, in a way, it's a cool thing that they can have this sort of flexibility with learning other sounds, but it's a when you're an expert at something, you need to um, use heuristics, and you need to kind of be efficient with, like, how you're
Yeah,
distributing your resources. Like
yeah,
runners need to, like, kind of use very efficient muscle movements that aren't overly, all over the place or something like that.
yeah.
Yeah. Um,
Yeah, I think that's a good
yeah.
analogy. And yeah, like people with neurotypical development are experts of language use. And so, yeah, the analogy that you're giving makes a lot of sense to me.
Yeah. Yeah. Cool. So you also have some research in pediatric epilepsy.
Yes.
Can you describe some of this as well?
Yes. So I'm involved in a project right now where data was collected in children with epilepsy when they were implanted with electrodes. And that is something that is only done for clinical reasons because these children were not responding to medication for the seizures. And so, in order to for them not to have seizures anymore, they need to find where the epilepsy is originating from in the brain, and they need to know that with really high spatial resolution, very precisely where is that coming from, because then afterwards they will resect some brain tissue where the epilepsy is originating from, and that way, hopefully, or most of the children will be seizure free afterwards. And so, for this procedure to find where that locus is of the epilepsy, the children get implanted with electrodes or electrode probes that are called stereotactic EEG. And so they are then in the hospital for multiple days, and where they are just basically waiting to have a seizure so that the doctors and surgeons can see where it's really coming from, that seizure. And so, because, yeah, often they have to wait a few days, they are just in the hospital waiting to have a seizure. And we kind of use that window of opportunity to do some research with them if they are up for it. And one of the studies that I'm involved in has asked children to listen to some natural speech, natural sentences. And so I'm working on this data set right now. It consists of 100 children, and it was collected at the Cincinnati Children's Hospital. And this is a collaboration with Ravindra Arya, Dr. Ravindra Arya. And so this is a really valuable data set. And I am looking into understanding whether when children hear language, these stories that we play them, do the language representations at different levels mature at different time points in development, because this data set has children of age 4 until age 20, so adults, and
Mm.
or young adults. And
Wow, that's a
so,
big age range.
yeah, so that's really interesting. And with the hypothesis that lower level sensory features might mature earlier in development, um, such as like does the brain encode how the amplitude changes over time during natural speech, or phoneme encoding? And then I'm also hypothesizing that the higher level features like entropy, phoneme entropy, or semantics will mature later in life. So that is kind of what I'm investigating right now. And yeah, there were some preliminary results, but I want to be cautious with talking about results
Sure,
because I'm still like in the middle of investigating this. But yeah,
sure.
that's
Well, I really like this idea. Like, so is this what you refer to as the speech processing hierarchy?
yeah. So
Okay.
my advisor during my postdoc now, Laura Williams, she has brought forward the idea that there is, so to speak, a reverse language hierarchy. And what that refers to is that during natural language processing, most people assume that we first hear the acoustic sounds, and then from that we put them together into words or syllables and words, and then we attach meaning like serially like that. But Laura has found in her research that actually um, higher level features such as syntax and context, like semantic context, are actually decodable earlier than the lower level features such as acoustics and phoneme related stuff. So
Yeah,
yeah, that's this reverse language hierarchy. And
got it.
yeah, so this is indeed related to the hypotheses that we came up with for the pediatric epilepsy data set.
Oh, very interesting. Yeah. Yeah, this is a really cool um this is a really cool idea. I think it squares with a lot of the developmental like, kind of psychology research, specifically like usage-based ideas like Tomasello, and just showing how kids are so attuned to intention and meaning almost
Mhm.
first. Like that's like the first thing they're processing. And like, a lot of we don't process letters first, right? We process whole, it's usually not even like words. It's like maybe a phrase, like, or something like that, like come on, or let's go, or like something that like
Yeah.
kids are not yet understanding that it's separate words. It's like you almost got to get the context and the meaning first with like whatever chunk it is, and then through developmental time, when we learn the alphabet and we learned uh you know uh different what phonemes sound like what, like
Yeah.
then we start to break these things down later, and then we're able to like use those ideas to then make new sorts of things. But it does feel like a lot of that, what we, quote unquote higher level stuff, is like coming first.
Yeah, yeah, indeed. Yeah, so it might also be that a hypothesis goes the other way and will not find what we thought we would find. That's the fun of research,
Oh
um,
yeah, yeah, right.
trying new stuff. So yeah, I don't know if it will be the opposite of what we hypothesized, so that maybe higher level features would be maturing earlier. And
Interesting.
yeah,
Yeah.
yeah,
Or together, or
yeah. But yeah,
so.
one other aspect, sorry if
No, go ahead,
yeah.
please.
So one other aspect of the pediatric epilepsy research is that the epilepsy can interfere with language development. So you get a lot of kids with epilepsy that have some delay in language development. So that is another stream of research that I'm also interested in.
Mm,
And um, yeah, so for that, we are doing further research at Stanford, where I'm doing my postdoc right now to understand, yeah, in a person, in a child, for example, that is minimally verbal, which language representations are still encoded in the brain and which are not. Yeah, so
wow.
that's another part of that kind of line of research.
We'll have to get you on for a part two
Yeah,
to talk about that research.
give me
Yeah.
5 years.
What is the next question you're most excited about? Is that like kind of what your research is going to be focused on in the future, or um, are there
It is.
things still in aphasia that you want to continue to follow?
Yeah, I think in the future I definitely also still see some aphasia research, and but it's not something that I don't have any active research going on right now in aphasia, except that we will publish the data set that I collected during my PhD will be published open source because of what I mentioned, because we studied natural language processing, the hypothesis space and the features that you can annotate the story for is really large, and I have by no means explored all of the things you could explore in that data set. So yeah, hoping with that open source data set publication that the research on that aphasia data set can go on
Yeah.
and yeah, beyond me. And then for future research currently, yeah, I think the pediatric epilepsy kinds of questions are my main focus right now. But I'm also working on a study where we, together with Irmak Ergin, she's a grad student or PhD candidate at Stanford, and we're working on developing, or we have developed a slider that you can manipulate with your hand and your fingers to indicate how much you understand in the story at every moment in time. So it's a real-time behavioral measure of comprehension. And
Oh, cool.
yeah, in
It's really novel.
yeah, so we're doing now a follow-up study to this first slider validation study, and this will allow us to yeah, directly link the brain activity in a time-resolved manner to this behavioral measure of comprehension.
That's really cool.
Yeah,
Yeah, I can see how your kind of your psycholinguistics background is like sort of driving some of these questions in these other domains, like related, but more
yeah,
clinical domains.
yeah.
That's cool.
Yeah. But and that so we are testing this in healthy adults, and we are manipulating speech in different ways. For example, one is by asking people to listen to a language that they don't know at all, and then
Mm,
a language that they know maybe a little bit of. So a bit going into the multilingual direction as well. So that's something I'm also excited in for the future.
cool. Yeah, wow. Like, so you're so across the board. That's really awesome. Covering so much ground. Um, yeah, this is a bit of a random question, but I'm just wondering, like, in your work with either any of those three groups that you talked about, patients with aphasia, or dyslexia, or pediatric epilepsy, are there any like kind of personal stories that you remember from like anecdotes that you remember from working with any of these people?
Yeah, for sure. So doing that clinical internship in the hospital in Aachen that I did during my master's, I had a patient with aphasia that was, yeah, in his like 40s and had young kids, and
Mm.
he had a profession that was really intellectual, and it was just really hard to see how someone that is still really intelligent is just not able to express anymore yeah, the ideas that they have, and yeah, communicate to live a fulfilled like life and
Yeah,
just be socially isolated. I think that is always something that kind of unites all people with a language disorder, the social isolation. And many people that I've worked with in these studies have reported that. And yeah, even though they might
yeah,
have different types of language problems, that part seems to be generally, yeah, just the quality of life, and the social isolation is a big problem, like in their daily lives.
yeah.
Yeah.
Well, this is like really like the important steps towards figuring out how to, you know, give the best interventions that we can. Because I feel like, in the past, it's like I think we haven't understood, we don't have a clear picture for a lot of things. But in aphasia, I think uh, it was, at least in grad schools, taught as something that was so black and white. Like you learn these like very um, these little boxes of like, okay, this one's expressive language and this one's receptive language, and then when you get into both the weeds of neuroscience and also of the human stories, you realize like these things are different in how they manifest in people's lives, based on all of how people are different in general, but also like their own life journey. I mean, to have it at such a young age too is, I'm sure, it's quite devastating to not be able to, you know, um,
Yeah,
communicate
totally.
that phase.
Yeah. And in pediatric epilepsy and also dyslexia, of course, the educational attainment is different when you have these kinds of disorders, and how it like affects your whole life and what kind of um, jobs you might be able to do. I mean, it's of course case by case. Some people are able to um, like find different strategies, coping strategies, but yeah, it's just harder.
Yeah,
And yeah.
yeah. If we could really figure out, and we are, you're helping to illuminate this by, showing what aspects of this are we missing, and in what ways could the real some, or at least some part of the cause be in these lower level, actually speech perception, or speech processing aspects.
Yeah, yeah,
Yeah.
totally.
And then how
Yeah.
can we help with that, if that is an issue?
Yeah, understanding the disease mechanism, so to say, in the brain, what goes wrong is, of course, very important to understanding how maybe in the future we can design brain-computer interfaces that can help at least some of the patients speak again, or yeah, different types of interventions that might target lower level functions in, for example, people with aphasia might help. But yeah,
Yeah.
so lots of research to be done for sure.
Yeah. Yeah. What would you say are kind of, and maybe this, you've said this already, but the biggest takeaways from your research, and how has it, if at all, changed your view of what language is and um, communication?
Big question.
Yeah, big question.
Um, I think the research is going in the good direction right now, really, with also large language models enabling a new way of trying to understand what is happening in the brain and just these naturalistic data collections of like listening to natural speech or producing natural speech. Um, these kinds of things are super important, I think. So I think, yeah, that's kind of like my takeaway that we're going in the right direction and yeah, there should be more of this kind of research,
Yeah,
but also other research that is more experimental, like less natural, is also super important. So I'm not saying that that should not exist anymore, but I think actually a good mix is probably the best idea.
yeah.
Yeah.
I think you mentioned at some point like ablation studies. Are you involved in doing any work with LLMs or um,
Yes.
AI?
So I am collaborating with a PhD candidate, Nathan Roll at Stanford, and he is looking into ablating large language models. And then he ablates different models and in different ways and sees which ones have similar error distribution patterns as human aphasia and different types of human aphasia. So that is another way, like how large language models can or allow us to probe different questions because now we can like create these artificial lesions in the
Yeah,
large language models, which obviously we can't and really shouldn't do with
yeah,
humans.
right.
So this is a super exciting time for that reason as well.
Wow. Are you finding anything that any correlations between, and how would you make those analogies like to like
Yeah, so
uh
that research is still in development, but I think so far Nathan has found that many of the ways that you ablate language models have slightly different error distributions than in those LLMs than in human aphasia. Um, but yeah, for more specific results, you might have to wait for Nathan's publications.
well that would really that makes a lot of sense given your research because if a lot of this is in lower level speech processing, why would you see um, the same patterns if you're just affecting the higher level
Yeah,
language structures?
yeah, that
So,
makes a lot of
honestly,
sense. Yeah, totally. And yeah, I mean, I think we are not the only ones that are doing LLM ablation studies, and I think soon there will also be studies that look at ablations of speech models or like models that integrate both speech and language levels. So that will be
interesting.
super interesting to see where that research is kind of going.
Yeah, we're in such a crazy time.
Yeah,
I think for everybody, but language researchers, I think especially have this like crazy uh,
yeah.
new technology that
It is a
yeah
crazy time to be in the language research field, but like in the best way. It's like super interesting to see all these new directions that it's currently going in.
yeah yeah. Well, Jill, thank you so much for your time. It's wonderful to talk to you.
Yeah.
And yeah, I was just wondering if you have any asks of the SLP audience. Can people get in contact with you if they have any questions?
Oh yeah, people can definitely contact me if they have questions to about
Collaboration
anything.
opportunities.
Oh, totally. Yeah. Reach
Yeah.
out, please. And yeah, otherwise just thank you for all the amazing work that SLPs do and yeah, how they help older people with language disorders. It's amazing.
Well, thank you as well for your research and helping inform us with, for how to best think about and best intervene. And yeah, appreciate your time.
Thank you. I
All
appreciate
right.
your time as well. Thank you for inviting me.
Of course. Take care.
Thank you. Bye.
Hey everyone, just a quick note before you leave. If you're liking this podcast, it would mean the world to me if you subscribe. I'd really love to hear from you too. If you got any notes, some guests that you want to hear me interview, I welcome all that. So please contact and be in touch. All right, take care.